Hello and welcome to Calculus tutorial. Today we're going to take a look at tangent lines. That's what we studied in class. And tangent lines in the past have often become the bane of students' existence, and it's the one thing I don't know why. Students don't like it so much because it is fairly easy. And I think the key is just to realize that a tangent line is just a graphical representation of the derivative. And oftentimes, yes, we do want you to calculate that line and make the equation, but that should be just some Algebra 1 skills you learned a long time ago. So first, what is a tangent line? It is tied to what the derivative actually is. So here we have a graph, and we're going to think of the derivative. So remember, the derivative is the slope at one point. So you've often seen me draw the slope like this. Okay, it's basically just the angle of the graph. Well, if you imagine that angle as not just an angle, but a line that goes forever, okay, through that point, just like that, that is a tangent line. It touches the graph at just one spot right there. It's in fact parallel there because it has the same slope as the function does at that one point. That is what a tangent line is. And so to continue looking at that and what that looks like, let me give you a moving view of that. Let me get a bigger eraser here. So here we have a line between 2 points here. This actually does have a name. This is called a secant line. So remember, a secant line is between 2 points. But if I take that secant line and I start moving these two dots, these 2 points, closer and closer together, eventually the 2 points meet, and we have the line through 1 point, and that is the tangent line. Okay, it's the line that only goes through 1 point. As you can see, it has the same slope as the slope of the function at that one spot. Oftentimes we think of a tangent line as only crossing the graph once. Yes, I can see it crosses the graph over here, but we're not worried about that point. Just in this area, you're just brushing up against the function in one place. So that is our tangent line. And that should be familiar in that we did this at the very first week of school. We took the slope between 2 points to find the derivative, but we made those 2 points extremely close together. And as you can see, as they become closer and closer together, we essentially have the slope at 1 point. Alright, so where are we here? This one. So now that we have an idea what a tangent line is, let's actually calculate one. How do we actually calculate a tangent line? So pretty much the same graph here, and we have the equation for it up at the top. So how can I write the equation of the line that is tangent to the graph right here? That line there. Well, if you're going to write the equation of a line, it takes two things. It takes a slope, and it takes a point. Those are the two things that we need. You'll hear me say that over and over again. What do we need for a tangent line? Slope and a point. Well, slope, another word for slope, is the derivative. So to find the derivative, that's the first thing you want to do. So y prime, 3 times 3 is 9x squared. Now this one, 2 multiplies down, we have 6x. And then negative 12, and the derivative of the second negative 12 is just 0. Now, so that is our slope equation, but where do we want the slope? We want the slope right here, right when x is equal to 1. So we want to find y prime at 1. So we'll plug in 1, that's nice and easy. We can pretty much do this in our head, it looks like. So we have 9 plus 6 minus 12. So that y prime at 1 is equal to 15 minus 12 is 3. All right, so now we have our slope. The rise and the run is 3 over 1. That is our slope. Now, what point are we actually doing this at? It is the point 1, comma, somewhere down here. What is it? I can't see what the y value is, so I actually have to plug in 1 into my function here to see what that is. So if we plug in 1, we get 3 plus 3 minus 12, which is negative 24, and 6, which is negative 18. All right, so we know our point and we know our slope. That is enough to write the equation. So you've got two options here, and you've just got to find the one that works for you. The one you're probably more used to is slope-intercept form, y equals mx plus b. It's a little bit longer to use this way, but it's most familiar to everybody. So m, of course, is our slope, so we can put in 3 in for m. Now b is our y-intercept. We do not know our y-intercept. As you can see, it's going to be somewhere over here, but we don't actually know what it is yet. And so to solve for that, what we're going to do is plug in 1 for x and negative 18 in for y, and that will allow us to solve for b. So we subtract 3 from both sides. B is equal to negative 21. And you can see pretty close here. It's probably actually supposed to be right here, but my drawing is not that great freehanding it. But it actually looks reasonable. So now that we know what b is, we can finish off our equation. Y is equal to 3x minus 21. And so now we have the equation of that tangent line. Hopefully that looks reasonable. 3x minus 21 is that equation. There is one other way you could do that I at least want to show you. That is point slope. Another way to write an equation is point slope form. I really got to say this is the better one. Most students don't use this, sadly, but it's faster, and when we get down to it for the AP test, time is of the essence. So if you remember point slope form, it is y2 minus y1 is equal to m times x2 minus x1. And then you just simply plug in all the values. All right, the first one just stays as a y, minus the y value. Our y value is negative 18. You can see how that will become positive. Is equal to m, which is 3, times x minus our x value, which is 3. And there is the equation of the line. Oftentimes on the AP test, it just says write an equation, and that is an equation. Yes, if you distribute And if you, let's see, that becomes positive, and then subtract the 18 over, you will get the same answer. But for now, if you need an equation, that technically is an equation. All right, so that's sort of a rough idea of what tangent lines are. Hopefully that helped.